Our next session is, we will start for the next session. So our next session will be delivered by Professor Ajay Kumar Rai sir. He is Padma Shri and former director IIEST Shibpur, and he is a former professor of IIT Kharagpur. He will be delivering on recent advances in machine. Professor Ajay Kumar Rai sir obtained his bachelor's degree from Bengal Engineering College Shibpur, followed by M.Tech and PhD from Electronics and Electrical Communication Engineering Department of IIT Kharagpur. In 1980, he joined the same department as a faculty member. In IIT Kharagpur, he was instrumental to establish School of Medical Science and Technology. Here, Professor Ray was the chief investigator of a number of medical imaging projects sponsored by Texas Instruments. As a part of this project, his team has filed 6 USA patents jointly with Texas Instruments. Under his leadership, his group had initiated a number of medical projects on molecular imaging, image processing, medical instrumentations, etc. He was secretary and chairman of Nehru Museum of Science and Technology at IIT Kharagpur as from 1991 to 2006. Professor Reyes was associated with the University of Southampton as Senior Research Fellow during 1989 to 1990 and led a research group on image and video processing of adverse in USA during 2004 to 2005. On leave from IIT Kharagpur, Professor Ray joined Bengal Engineering and Science University, Shibpur, West Bengal as Vice Chancellor on 1st March 2009. He was also the first director when BESU transformed to Indian Institute of Engineering, Science and Technology, IIEST, with effect from 4th March 2014 till his return to IIT Kharagpur in May 2018. Professor was instrumental to bring major change in academic curricula of IIEST and converting the compulsory 5-year dual degree program to optional was a landmark step in this regard. His research interest includes medical imaging, image processing, pattern recognition, machine intelligence, to a few to name a few. He has successfully completed more than 20 research projects sponsored by several agencies like Defense Research and Development Organization, Department of Atomic Energy, Department of Science and Technology, and so on, jointly with Intel Corporation. He has co-authored about 150 research papers in international journals and conferences. He has authored 5 books published by international publishing houses such as John Wiley, Tata MC Grohill, Prentice Hall of India, and Taylor and Francis publication, including one in Chinese. Professor Ray is a fellow and member of many professional bodies and is involved with a large number of universities in various academic books. Professor Ray retired from IIT Kharagpur on 28 February 2019 in the 40th year of his teaching career. Presently, he is the director of JIS Institute of Advanced Studies and Research, Kolkata. He is the recipient of the Distinguished Alumnus Award from IIT Kharagpur at the 65th convocation of the Institute on 27 August 2019. For his outstanding contribution in the field of science and engineering, Professor Ray has been conferred Padma Shri year by GOI on the occasion of Republic Day on 26 January 2017. So, sir will be delivering the lecture on recent advances in machine. Sir, I will request you to please start.
Thank you very much for the introduction. Am I audible?
Yes, sir.
Hello.
Yes, sir. Yes, sir.
Okay. So to start with, I mean, this is one of the most exciting areas of today. That is, the area of machine intelligence. I will like to, share with you some of the evolutionary aspects of this very important area. It is important that whenever, you, the teachers, you are teaching a subject, please try to tell to the students about the historic aspect of, certain ideas, at which point of time those ideas had cropped in. Remember that nothing has come all on a sudden. So everything, we had a, a historic or an evolutionary approach. So with that in mind, I thought that let me initially talk about a little bit about the historic, the evolutionary approach of, this great area of machine intelligence, AI and machine intelligence. Is it visible?
Yes, sir.
My
It's visible.
PPTs?
Yes, sir. It is visible.
PPTs are
Yes, sir. PPTs are visible, sir.
okay. So, so this is a story. Let's just go through it as a story of evolution of neural network. And we have started from 1942. To make it interesting, I thought that, okay, let me tell you simply stories. And you will see that how brilliant ideas had come up at different points of the history. Say 1942 means Second World War was going on. And during that time, in Second World War, for the first time, there was a birth of neural network. We all call about this area as a neural network. And that was in 42, 43. And who had done it, as I was mentioning in the morning, that it was by the neurophysiologist Warren McCulloch and the mathematician Walter Pitts. For the first time, they gave a model about neurons. And then they also showed an electric circuit, that electrical circuit which is just a model of a human neuron. So this was a great thing. And this paper is considered to be one of the most pioneering work. Where was the computers? 42, 43, there was de facto almost no computer. You may sometimes wonder that we had only, those 8-back, ENIAC, and those were all bulb type of very preliminary computers. But the whole area of neural network, it developed before that. And at the same time, there was another gentleman whose name you must know, and he is none other than, the grand old man of computer science who had talked about for the first time the stored programming concept of the present day computing. So this is important to know about. And the third person who had contributed really to the computing science maximum, especially in the area of AI, who can be in a sense considered as the pioneer of the modern day AI. His name is Alan Turing. Those who are from computer science or electronics or IT background, you will be knowing about Alan Turing's name. And he, for the first time, had talked about the Turing test, a very fairly simple test. That means, how do you know that from a set of questions that a computer or a machine, in general, as we call it, or a human being is a human or it is a non-human, that is a computer. So this test was really remarkable. Imagine that in 1950s, he was talking about the Turing test. And this is the first thing that any computer science student will have to study in his second year or maybe, in his second year course. And before that, in 1949, we had the Habe. Habe was again another great personality who had talked about, the neural network which McCulloch and Pitts had initially given the model. So Habe was the first to really make a slight advance in the area of neural network. He could say that how the network could learn. And so far as the computer, since, even in 1949, 50, where was the computer? Even, semiconductors were first developed in 1947. So in 1952, for the first time, a computer program was written, and a computer program which is in today's parlance, which should be called as an intelligent computer program, which could play checkers. And this was developed by none other than Arthur Samuel. So Arthur Samuel, that way, was or may be considered as the first man to have written a intelligent computer program which could play checkers. You may say that, okay, there was, imagine in 1952, where were the high-level languages? There was nothing. There was no concept of any compilers. The formal language theory, which Noam Chomsky had talked about, that came in late 50s. 56, 57 was a paper by Noam Chomsky. Those of you who are in computers area, you know about that Chomsky's formal language theory, based on which the computer programs in high-level language were developed. Then the computer compilers came up, etc. But these were all, initial things. So far as the current day neural networks or artificial neural network is concerned, then I must say that it was in 1958, this gentleman, Frank Rosenblatt, he had given the development of a first artificial neural network, and very simple neural network, because 1958 was still, in its infancy. And this network was known as perceptron. Perceptron means it was a machine, a computer program, which could detect or which could perceive. Perceive means which could classify the incoming patterns into two or more classes. So this was a great thing, perceptron, 1958. And immediately after that, in 1959, that Bernard Widrow and Hoff, they were in Stanford University. They developed two excellent models. One was known as Adeline, and that could detect the binary patterns. And the second one, immediately thereafter, was known as multiple Adeline or Madeline. In fact, in detail, I cannot talk about each one of them, but then it is very important that if you could know what these people did in the early days of the development of today's machine learning. So Minsky and Peppert, this gentleman, Minsky, he was actually Rosenblatt's friend, it appears. And he was not very happy with Rosenblatt's perceptron. Rosenblatt, what did he do? He said that, okay, here is a machine which can classify the patterns, which can perceive. Just you give, say, two different, images, it can distinguish between a cat and a dog, like that. So, but then Minsky said that perceptron is not a neural network in the real sense, because it had lots of limitations. And after several papers in this area, so Minsky and paper, they wrote a book. Minsky was one of the outstanding personalities, and again maybe considered as one of the founders of AI. So two parallel things were going on. One was some people were working in the area of pattern recognition and all. Artificial intelligence, again, if you talk about, then it took a turn where, which started, as I said, with Alan Turing, but then Minsky gave a real boost with others. And during the whole of late 60s and 70s, frankly speaking, there was not much of development in the area of machine learning or neural network. Why? Because Minsky said that these perceptrons, these could classify the patterns. I understand that you, by this time, since you had two sessions, you know that what is meant by classification. If somebody has got any questions, you can immediately, switch on your microphone and ask me the questions. I can repeat. But then this is interesting. He said that in fact, in pattern recognition, the patterns, if you consider them as two-dimensional patterns, so it has got two features, X and Y. And then if you can draw a straight line demarcating between the two classes of patterns, then this is known as a linear classifier. So the perceptron that was developed by Rosenblatt, it was a linear classifier. That means you could only classify those patterns which could be classified using a line. Okay, so that was one of the limitations. But in real life, most of the patterns, they will appear in such a way that you will not be able to find a straight line which will demarcate between the two pattern classes. So these is known as non-linearly classifiable patterns. So Minsky and Pepper, through this book, then everybody came to know that, okay, this is a very preliminary work, that is perceptron, whatever has been done. So funding gradually started reducing. And everywhere, research means you need to do fund, to get fund. Without funding, you cannot do the research. So despite the success of the initial things, there was not much of progress in the development of neural network until the late 1970s. So somehow, people thought that all these perceptron, etc., they are no good. But during this time, there was a lot of developments in game theory, in theorem proving, in the theoretical computer science, and which gave a very good basis to the artificial intelligence. Again, I cannot go much in detail because AI is again another very important area. Of course, this machine learning is a part of AI. And when I'll talk about deep learning, that is also a part of machine learning. I mean, with further developments, newer and newer algorithms are coming. So the popularity, I talked about von Neumann architecture because von Neumann is the father of computer, that stored program computing. It's not that he has only talked about the computer architecture. Many people, they thought that, okay, he has given the stored program, today's computer model. But it's not that. Von Neumann had given so many concepts for the first time. Those who are working with cellular automata, the initial, all the papers were von Neumann papers. If you talk about, today many people, they are working in security, data security, cyber security. Even on these kind of things, that time will come when the computers and the programs may be, attacked by some kind of virus. Again, von Neumann had talked about it. So neural network and the stored program usual computing environment, they are two parallel kind of works. Because in von Neumann architecture, they were considered to be the machines which could do computation. But neural networks, during the initial part, it was conceived that they should not be used as a computing network. This is very important because a lot of physicists, neurophysicists, during 1980s and 90s, many of them, they were very angry with the computer scientists because we used to call it as artificial neural network. And they used to say that, look, these are all nothing. It works, that's fine, but then it doesn't have much of correlation until unless you can really mimic the human, the biological neuron, which is so interesting. Again, I cannot talk much about that, but then if somebody can take up, then in India, we need to coalesce these two areas. One is the biological neural network and the other one is the artificial neural network. A lot of work is now going on in these areas, especially again in United States and some parts of Europe. So in 1982, there was one thing that Japan, they said that, okay, they will be focusing on more advanced neural networks. And that again had, because America, they need some kind of a trigger. And the research, really speaking, most of the research has been done mostly in the United States and then in parts of Europe. So with Japan's, entry into the field, the American funding immediately enhanced. And a very important development that came was Rummel Hart's one book, which was known as Parallel Distributed Processing. When I was teaching this course in 80s, late 80s, early 90s, I used to give, I still have that book. It's quite a thick book. Original book on, we used to call it as PDP, Parallel Distributed Processing. And I used to tell my students that until unless you study this book, you will not really get a feeling of what neural networks are. They were all from Stanford University, psychology department. This is interesting. And then they thought that this perceptron which Rosenblatt had talked about, it is not doing justice because it has become only a linear classifier. So they said that if we can add more number of layers known as hidden layers, then we will be getting a multi-layered perceptron, which will be able to classify the patterns which are non-linearly separable. So this is a very interesting thing. And this whole work, it again led to the rejuvenation of the area of neural network with the introduction of multi-layered perceptron. Because many of you might have started working in this area. It's known as MLP. And slowly this multi-layered perceptron, they can learn. Now we have to understand, and it takes a lot of time because these multi-layered perceptrons, I still remember in 1990s. And 1990s means, imagine that in almost 30 years back. So many of my students or my colleagues, the network, that MLP, it used to take a lot of time for convergence. So convergence was a big issue. And in the evening, you start the work, you go for dinner in your home, have your dinner, come back maybe at 10 o'clock. In IITs, we had that culture. Come back at 10 o'clock and come to your machine, your computer in your room, and it's still not converged. Imagine that for 4 hours, 5 hours, it was not converging. And then gradually we came to know that why the algorithm is not converging. So there are lots of issues, and it may not be proper to just, casually go through. But then every simple point has got a lot of things to do. In 1997, I will again come back to this multi-layered perceptron later on. So there was again another very important development. That was the IBM's Deep Blue. and as you know that the contemporary world chess champion, nowadays I forget the names, and in that chess playing game, Deep Blue had really defeated the world chess champion. You all know his name. I'm just forgetting at this point of time. So that was a great achievement. That means a computer program. And I remember that in 97, all the newspapers, they had the headline that IBM's Deep Blue defeats again that person. So
Gary
when
Kasparov.
right. Kasparov, yes. So he was a Russian, grandmaster, and he was defeated. Yeah. And since then, since this was for the first time, we will talk about lots of such, programs which have been written since then, and which could defeat a lot of grandmasters anywhere. So there have been a lot of developments or advancements from 1997, 98 onwards. Another big place, see, as researchers, you should know that as IBM is one of the major players in everything that you see today in computing area, the other place is AT&T Bell Labs. And AT&T Bell Labs, initially these were the two organizations, as I understand, other than MIT and Stanford. Generally, these four organizations had contributed more than 60 to 70% of what we see today. Everything. So AT&T and Bell Labs, they started a work on digit recognition. Now, this is very interesting in detecting handwritten postcodes. You will be surprised that when we talk about the work in India and how they work, this is a project which we had submitted, my first project at IIT Kharagpur from DST. And that was this pin code recognition. Imagine in IIT Kharagpur, that is my first project as teacher. Two projects were given by DST. One was this pin code recognition. Those days we used to write on the postcards, and then you have to recognize each digit, and then you have to make an arrangement so that each of the places, suppose 721302, IIT Kharagpur, IIT, Kharagpur pin code. So it should go to one slot. Similarly, Calcutta things will go to another slot. So you have to not only recognize the different handwritings, but also you have to sort them in different bins. So they did it. We started it in 1980. We completed that whole thing, submitted the report, and never gone back. Imagine in 1998, when AT&T and Bell Labs, when they do it, they do the complete thing. In our country, going back to my own career and our own research, lots of things we have done. In fact, only the other day, I was talking to this gentleman, maybe again another CEO of TI, Texas Instruments, Bobby Mitro. Bobby also was my student at IIT Kharagpur, and he did his project also with me, BTech project. And can you imagine that in his BTech project, I have told them that those days in 1985, I suppose he did his BTech. So I told Bobby, you assume that you do not have any keyboard of a microprocessor kit those days. So all these programs that those who are teaching, say, microprocessors will have to be spoken. Move immediate B or move immediate accumulator, say 00 or FF. So the computer should be able to understand the spoken words. Imagine in 1985, a BTech project. And not only that, you have to see that, okay, it is syntactically a correct statement. Assembly language programming. Because since I do not have any keyboard, I have to only just the voice commands I have to give, and then it should be able to recognize. And then not only recognize, it should be able to really implement that statement. So you have to see that, okay, in the accumulator, you get FF after this is talked about. So even today, for example, if I say that I do not have any keyboard, assume only through the voice, because this is also part of pattern classification and machine intelligence. So you have to write an intelligent code so that without a keyboard, how much can we go? Like say handwritten postcodes. Now postcodes nobody use. But then, so for doing all these things, we need learning. Again, learning has got three different types of learning. One is known as supervised learning. Another one is unsupervised learning. The third one is reinforced learning. Supervised learning means, this is the other name of supervised learning, is the learning with a teacher, where the whole idea in the early phase was to classify the pattern. It may be visual pattern, as I said, that all the pin code numbers will have to be classified. Or maybe that you have written something, text recognition. You have written some text data and you have to recognize. How do you recognize handwritten data? So thousands of such samples will have to be first collected. So this kind of data collection cost is almost zero, because you don't have any cost in collecting the data of handwriting. You tell your 100 friends, let them write all these ABCDs and all. You go to any primary section, you collect all thousands of samples, and then you have to have a computer program which is intelligent program and which can learn using supervised learning. That means you have to tell the computer that, look, this is A, this is another A, this is another A, etc. Finally, when the computer learns, then it will classify. There are lots of classification strategies, techniques, lots of them. And these classification techniques, again, can be divided into several kinds of classifiers. One of the classifiers, they are known as parametric classifier. The second class of classifiers are known as non-parametric classifiers. Since I have to go up to deep learning, so I doubt that I will be able to talk on detail about each one of them. But then all these supervised learning, initial days, it was based on statistical processing. So you can only classify statistically. And like I was a fan of fuzzy set theory, so we used to do fuzzy classification. That means we used to think or considered a pattern not as a stochastic event or a statistical event, but the patterns were considered as imprecise fuzzy events. So imprecision in classification, imprecision in whatever we do, we see, it can be imprecision resulting from statistical imprecision, or it can be fuzzy imprecision. So there's a difference, subtle difference between the two. Techniques are also different. We cannot talk about fuzzy sets now because that will again be another big area. So one is this classification. Generally, you may consider statistical classification or fuzzy classification. The third type of classification is very interesting that not many people are working on that now. Although the third type of classification, it is known as structural classification. Every pattern that you see today around you, which you have to learn, using which you have to train, remember that how does one pattern differ from the other pattern? It is only in the structure, in the form, in the morphology, in the color, in the texture, in various such things, you can classify. So I had worked very extensively on structural pattern classification and using fuzzy set theory. And even today, so structural classification means every pattern can be considered to be a graph. So you can now convert any kind of, suppose, three-dimensional, scene analysis. You take a photograph of your house. So there is a floor, there is a ceiling. On the floor, there are tiers. You have to understand that these are tiers. As I was telling in the morning, you are given a complete picture of your room. At the end of the day, your machine learning technique should be able to say, to write an essay on your room, that how many chairs are there, how do they look like, how many sofas are there, how many photographs are there, how many fans are there, how many lights are there. So, and then it's not only that how many, they are having a structure. Say the light may be on the right of the fan, another light may be on the other side of the fan. So like that, I mean, so there is a structural correlation of these patterns. So using that pattern classification is also known as structural or syntactic pattern classification. You will rarely see people talking about it, but again now it's a little bit difficult in the sense that you have to, consider, and you have to make a semantic network. This kind of a graph is known as a semantic graph. Semantic means meaning. That means every relation in the graph, it has got a meaning. So it's known as semantic network. So semantic network based classification, structural classification or syntactic classification, this is a very interesting area, other than the general parametric and non-parametric classification. The other thing of supervised learning is regression technique. This is also a very important thing. The difference between regression and classification is you can use a same classifier, for example, a neural network, which can be used as regression. Regression means it's basically, the input-output relationship. In the case of regression, is one of the functional relationship between the input and the output. Output is also a quantity. Input is also a quantity. But in case of classification, output is not only a quantity, but it's a class. It's a class of patterns. So regression and classification, although they are of two different groups of activities, but then regression is very important area today in machine intelligence, because in many cases, your input and outputs, they should be numbers. For example, in business, you have to, the stock market prices are changing, continuously changing. So stock market, what will be the stock value of a certain, product? Maybe that after 2 months, you can do this kind of this is useful, and this is known as predictive statistical analysis. And by regression analysis, you can say that, okay, this will be the, you can either do the descriptive statistics or you can do the predictive statistics. So prediction is now today a very important thing. What is the prediction? That after the COVID-19 goes away, what is the probability that another more lethal and more infective kind of, virus may appear? So you may predict that from the current, the genetic information. In fact, in my institute, where we have started a new institute, and the only of its kind in India, where we do not have any undergraduate, it's only postgraduate and research. On GIS group, they are funding it. So I have joined that, rather I have started that institute after my retirement from IIT Kharagpur. So it's known as GIS Institute of Advanced Studies and Research, where we are, trying to analyze lots of things in health science, data science, and interdisciplinary sciences in these three areas, mainly only PhD and then MTech. So regression and classification, it has got huge application even in healthcare, in health science. The second type of learning is known as unsupervised learning. So far as we talked about supervised learning, that is, initially the machine should be trained using known labeled training pattern samples. You know that this is A, you give that pattern sample A to the machine, that is the neural network, it should say that, okay, it is, and tell it that, okay, this is A. Another person writes A in another way. You train the machine by saying that this is also A. So as the mother or the father teaches the small kid, the parents, when they teach the small kid, they teach it exactly like this. So this is a cow, this is another cow, this is another cow. So what does the child do? It extracts the feature of the cow and how a cow looks like. That it must have so many legs, it must have a tail, then it may have horns, usually it may be white. So like that, all kinds of features, automatically the human beings, we can extract those features. So here, the major problem is the features you have to extract. So in these two areas that I am talking now, in supervised learning and in unsupervised learning, the features have to be extracted by the designers. So till 80s and 90s, our students, they were, trying to find out that what should be the best set of features and how many features you need for correct classification. Nobody knows. Somebody says, for example, face classification. Somebody came up with a fantastic result with, say, 19 type of facial features. Another student came up with equally good classification accuracy, and he has used only 14 or 15 features, facial features. And both of them, they claim that on almost 200, 300 samples, they have got fairly good amount of classification accuracy. That means their learning has been accurately done. Now let me come to unsupervised learning. In unsupervised learning, there is no teacher. This is also known as learning without a teacher. Supervised learning is learning with a teacher. Unsupervised learning is learning without a teacher. Naturally, the question that comes is it possible to learn without a teacher? The answer is yes. Again, sometimes I'll tell you some stories. So in IIT Kharagpur, many times my research scholars, I used to take them to one of the classrooms which is, which was usually not being occupied. And then there was a big board and we used to discuss on the board. And I had, frankly speaking, a little bit of chai ka, I needed chai quite often. So from the canteen boy, he used to get me tea. So then he used to not only give me the tea, after giving me the tea, he used to simply stand there. So I asked him that, what are you looking at? Because you have to now give tea to other teachers also. So he said that, no, I am looking at the board. I said, what you are looking at? So he said, I have not studied in schools. I do not know. Only thing I have studied, I have learned is there is ABCD. This is English, isn't it? So I said, yes, this is English. So then I thought that, okay, so he will never have an idea about. So I told him that, okay, his name was Bachu. Bachu, you go to the board. And I showed him 1B. And then I told him that you find the whole board was full with a lot of mathematics, symbols, writings. You find that where all you find this kind of a pattern, this B, And you imagine that a small boy who has never gone to a school, he could very correctly tell that, okay, this is B, this is B. He doesn't know what is B, what is A and all. He has never seen it. He didn't have any teacher. But again, it is with the similarity. In fact, Ansul was talking about, when I just joined, I found that Ansul was talking about similarity relation. So similarity relation is a very interesting kind of topic. So here also, the similar kind of patterns, they have got more similarity relations. So although I do not know that which one is A, which one is B, so in a very short time, he could identify that, okay, one of the characters looks like this, and he could also write B. All that initially he was not knowing that this name of this character is B or name of this character is A. Okay. So once he knew in an unsupervised learning, so whatever Ansul was talking about, this similarity relations, based on that, you can cluster. That means that two similar groups or patterns, they can be clustered together. They belong to one class. Another class, similar pattern, they will belong to another class. So in pattern, in say handwriting classification, the character classification, there are say 26 alphabets. So there are 26 classes. There may be 100 persons writing A in 100 different ways. So based on the similarity, whatever we do clustering, this is also known as clustering. That means the similar patterns should be separated together. This is also a kind of learning. So once you can cluster together, then you give a name that, okay, this cluster is known as A, this cluster is known as B and all. So for this clustering, you don't need any supervision. No teacher is required. Only finally you know that, okay, this class needs this should be called as supervised. I mean, this is known as character A, character B. Reinforced learning is rather new, and here the learning takes place in the midst of its environment. Because when you are, learning something, you not only learn the exact thing of interest, you also learn its background, its environment, and that will reinforce your learning process. It's very interesting. Suppose if you have gone to the seaside, the ocean, there you will be seeing lots of things. You are seeing, the waves of the water. You are also seeing the sand dune, the beaches. You can also see some of the, these eating kind of small places where you can eat. You can see some hawkers, especially in India. So the whole kind of things that will reinforce the learning and that will help you in finally correctly classifying when you can learn with respect to the environment. So this is rather new. Now in neural network, this introduction, we talked about that after Rosenblatt's perceptron in 1958, then it took almost say 16, 17 years till the book on PDP was published, and there we started a new field from 1986-87 onwards, which was known as the multi-layered perceptron. So in this neural network, I will stop for a moment and I will ask some of you that whether this has been already covered or not, or shall I continue with this, or you all know it. Hirok? Hirok?
Yes, sir. শুনতে পাচ্ছি, sir. Sir, you can continue, sir. Sir, you can continue, sir.
Shall I continue?
Yes, sir.
No, because if some participants,
no,
I will continue.
Yes, sir. No one have covered this.
Okay. So suppose we say that X is the input. Now here, X is the input means X is a vector. As you can see that there are three inputs. So we say that X is a vector which is having, a column vector with three values. One is input x1, input x2, input x3. Through these circles are the neurons. So there are three inputs. What are these inputs? Actually, in reality, these are the three inputs which are the three features. Okay, so the total number of inputs will be equal to the total number of features that you are using. You may ask that how do you decide that how many features will be there? That will be a good question, because we do not exactly know that how many features will be there exactly. So feature selection is a very important problem and a very difficult problem. Till, as I said, that whole of 70s and 80s, the major, or even mid 90s, the major, work was on identifying good features. Again, these features, they have got some very good, characteristics. What is that? That to have a good classification, okay, so input is three features which characterize a pattern. Output, there are two neurons. So these two neurons are known as the two classes of output. Suppose one class is anything, one class is cow, another class is goat. Okay, so two outputs. So in general, how many features will be there? Nobody knows. So features are some high valued feature. Suppose if you say that in case of images, I will give the entire image as the input. Can you imagine that how much amount of data it will mean? It's a huge amount of data, even if it's a 256 by 256 images. Each pixel, if it becomes one input, then so many input neurons you will require, and the whole problem will be going out of bounds. Computational complexity will be so high that you will not be able to do much. So there are input layer of neurons which must be restricted to minimal number of features. How do you know that which are good features? Remember that the features should be such that they should be independent set. What is meant by independent? That means x1 is one feature, x2 is another feature. One should not be dependent on the other. In the case of independence of a vector, it is defined as if any of these can be represented in a form of weighted sum of the other n-1 features. Any feature, there are n number of features. No feature should be able to be represented by the weighted sum of other features. I will tell you one thing. Suppose in the face recognition, somebody came up, one student came up that said, if we take the eyeballs, the middle of the eyeball, the distance between them is one feature. And then over the eyes, we have got eyebrows. So middle of the eyebrows is another feature. That will be wrong because these two features are dependent on each other. Okay. So the distance between the two eyes is exactly dependent on the distance between the middle of the two eyebrows. So that becomes dependent. So if you use dependent set of features, that is a bad strategy. So feature selection is not that easy. And there's a lot of mathematics which goes behind the selection of features. I'm not going into those things. But then, assuming that there are n number of inputs and m number of output is equivalent to the number of classes. In between, we have kept a series of other neurons which are known as hidden neurons. So this is, one is input layer neurons, one is output layer neurons. The middle layer is known as hidden layer neurons. So you may ask that what is the utility of these hidden layer neurons? as you can see that all the inputs, they are connected with all the hidden layer out neurons. Every input neuron is connected to all other hidden layer neurons. So this is a completely connected, neural network. And in fact, in human neural network also, all these networks, they are connected with each other. In human case, we have got trillions of neurons, and all the neurons, they are connected with each other. Now, the path which is more often traveled will be more reinforced. The path which is not traveled, suppose something has happened, you have never discussed, you have never thought about it. So it will remain in your memory, but then you will never be able to recall it properly. But some important days, the day you got admitted in the engineering college or your college, the day you became the teacher. Now these are important days of your life. So those days you will always remember, your school days. So interesting thing is you will always remember because the neural path will be quite often, they are quite, reinforced through major, the different kinds of events that take place in our human brain. So hidden layer, similarly, hidden layer, each hidden layer is connected to all the output layers. There are two output layers. You can see that each hidden layer is connected to both the outputs. How they are connected? They are connected through weights, which are known as weight vector. So we have got, the weight vector which connects input to hidden layer and hidden to output layer. Now, these neurons, initially, McCulloch and Pitt, when they had first talked about, they talked about this neuron only. Each of these neurons, they can do the weighted sum. That means weighted sum of its input. Followed by that, there is a nonlinear function. So this is very interesting. This is known as sigmoid nonlinearity. So it's known as sigma function. As you can see that we have written H is the hidden layer input. So there, the H outputs of the hidden layer, they are equivalent to W1x plus B1. B1 is a bias factor. What is meant by W1x? W's are the weight vectors from input to hidden layer. Every path has got a weightage. Okay, so these weight vectors, and then this will be multiplied with x. X is the feature vector, x1, x2, x3. Plus B1, that is known as a bias input. It has got lots of utilities, this bias. And then the whole thing, it is weighted sum. W1x is weighted sum plus B1. And then you apply a sigmoid function, which is a nonlinear function. 1 over 1 plus e to the power minus x. This is known as sigmoid function. In fact, I do not have that marker pen at my home, although I have placed order a long time back, but it hasn't come. So it appears that those marker pens are now not available in the market, but let me see when it comes. 2, 3 I have ordered for, so nothing has yet arrived. Otherwise, I could have shown you that, I could have used my marker pen and show you. Anyway, so this is the basic thing. Now, suppose initially the choice of these, and Y is the output of the output layer neuron. In these neurons also, there is a sigmoid function, there is a nonlinear function. So remember that nothing is linear on this earth. Even human neurons are not linear elements. They do the weighted sum, but followed by that, the sigmoid nonlinearity. It need not be only sigmoid nonlinearity, say tan hyperbolic x. That is another kind of very often used nonlinear function. Anyway, several nonlinear functions can be used. So Y also is equal to sigma, that is sigmoid function of W2H, that means H is the output of the hidden layer neurons. W2 is the weight vector which connects the hidden layer neurons with the output layer neurons, and B2 is the bias for output layer neurons. So these H and Y, they have been shown like this. So how many such neurons then are there? So if you do not count the inputs, then there are 4 hidden layer and 2 output layer neurons. And how many weights are there? It's very simple. 3 into 4, since there are 3 input layer neurons, plus 4 into 2, that is 8, total 20 weight vectors you have to find. How many biases are there? Every neuron will have one input which is known as a bias input. 4 bias inputs for the hidden layer neurons and 2 bias inputs for the output layer. So total then 6 bias. So this is 26, these parameters. What is meant by learning? When we say that learning, then learning means learning of these parameters, all these weight vectors. Once you know, as you can see, W1 and W2, all these weight values. Okay, initially you give the known pattern samples. Suppose you give A, assume that okay, the pattern can be represented by 3 features. Any, suppose class 1, give n number of features, n number of samples. Each case, these are output will be the top one, that is class 1. Suppose initially the weight vector should be randomly chosen, W1 and W2. So initially you give a pattern belonging to say class 2, which is the bottom neuron. So actually, if the weight vectors are correctly chosen, then the bottom layer should have more higher value than the top neuron. But then since they are initially randomly chosen, so there will be error. So output layer should be the top one, which is class 1, that should have higher value of output. But if not, then there is an error. So that error is back propagated through these weight vectors to the hidden layer, and again from the hidden layer to the input layer. So this kind of neural network is known as error back propagation neural network. So you can just have these, that these are the weights. These are the sigma are the activation functions. As I said that they are sigmoid kind of nonlinearity is 1 over 1 plus e to the power minus x. So how do we train? This is the training. So what does the neuron do? In simple McCulloch-Pitts has shown, x1 and x2 are the 2 features, w1 and w2. Just as I was mentioning in the previous slide, they are the 2 weights. They will be, weighted sum, sigma, w1 x1 plus w2 x2 plus b. That has to be kept, that is the bias term. And then it is fed to a nonlinear element, which you can see that this is a thresholding element. In fact, this is you can consider there as a sigmoid function or tan hyperbolic function. I have shown here a simple threshold value. So if w1 x1 plus w2 x2 plus b has to be there. The value, if it is less than a threshold, then it should be considered as 1. Output is that y. Otherwise, it will be belonging to the other class. Either it is class 1, otherwise it is class minus 1. So it has been shown as 2 class problem. So orientation of the line can be changed. As you can see that class 1, they are clustered in by yellow points. Class 2 points are clustered as red points. So biased inputs are required, and I am not going into much into detail. That is, let me just see that how the weight vectors are, this nonlinear terms is 1 over 1 plus e to the power minus x. In fact, Professor Maiti yesterday told me that you keep it a little bit simple so that everybody can understand. So I haven't gone much into detail, but then few of these. So this is a feature vector. These are pH samples feature vector. How many features are there? N features, x1, x2, xn. And the superscript P means this is the pH sample. So this is the mainly XP is the feature vector for pH sample. And the ith component of the feature vector will be XIP. Subscript is the ith component. Okay. So target vector, what should be the target vector? And if the output is not exactly what is desired, then this is the error. I was talking about the error. The error for the pH training sample will be sigma TP K, that is for every K is each of the features minus YKP whole square. So this is just the error function. And then these errors will be backpropagated. So this is again the neuron which usually should be written as, any neuron will be having a weighted sum followed by a nonlinear function. So these are kind of things which are, the error backpropagation, problem. But I will have to move a bit fast, so I cannot, I cannot really harp upon one point because these are all full one semester course. So there are many problems which does not have fixed number of features. So you may ask that, okay, how many features are there? Repeatedly, I have been telling the same thing. Number one is nobody knows that what are the best set of features. You have taken some set of features, somebody else may say that no, this is better set of features. So this is a big problem, and these problems cannot be solved by multi-layered perceptron model with fixed length inputs and fixed length outputs. In the previous slides, I have shown you that the number of inputs is fixed. N is fixed. It may be 10, it may be 20, it may be 30, it may be 5. The number of features. Number of output is also fixed. That is the number of classes of pattern. But imagine that there are large number of problems where we do not have any fixed length input, fixed number of features. What are these? The problems in speech recognition. In speech recognition, I have initially started with a specific note, and then, or maybe in music, then immediately next second I change it. Okay? So these rhythmatic changes, these are not fixed. Or maybe in case of time series prediction model. So you really do not know that time series, it goes one after another. Say the language, or maybe that a string of binary patterns are coming. You may say that your learning system should give you one if the number of ones is even. That is, if there are 4 ones, then there are 2 output classes. Output class should be yes. Yes means it's even. No means it's odd. How will you do that? Because constantly the number of inputs, 1, 0, the strings, it's not fixed. And there are large number of problems where it is impossible to choose a fixed context window. So the contextually, if you want to see, because when I speak something, it is always contextual, speech. Because I will interpret a particular word with reference to the context in which that word is being spoken. So how can you bring this context information in the learning process? So there are large number of such things in NLP, natural language processing. You really do not know, for example, sentiment analysis. You see a movie, and after that you say that, okay, this is a very good movie. Or somebody says that absolutely this is a lousy movie, very bad film. So how do you decide that? So sentiment, it depends again on the time series of the entire movie. Movie is every second, suppose if you assume that there are, n number of frames in the video, then every frame will have some kind of your own, sentimental sort of chords will be activated. So sentiment analysis, again, it depends on a huge number of, our a huge number of these frames. So keeping in view of some of the important problems with the standard, this error backpropagation network cannot solve. In fact, it is not only that this is only just an ML, that is a multi-layered perceptron. There are many neural networks. Many neural networks. I mean, for the unsupervised classification, there is one type of neural network which is known as coherence network. It is also known as self-organizing feature map. So I cannot go into those things. There are, at least 20 different, very prominent neural network models. We have just only talked about one that is most widely used, that is the, MLP. But then there are, so many other, and each one has got its own advantage and disadvantage. SVMs are being quite widely used in terms of the classification accuracy of the classifier. It gives one of the best results. So I am not going into those kinds of networks, but going straight into a class of networks which is known as convolution neural network, which got its prominence in the early 21st century, that is from late 1996, 7, 8, 9, etc. Those days we were unable to use this CNN because the convolution process, it needed a lot of computations. And those days we did not have the computers with GPUs and all, which are so easily available. Now, I think in all the colleges and engineering institutions, we have got lots of such machines, which are quite fast machines. And that's why during our times in 80s, 90s, it was very difficult to run a program. Convolution neural networks, since they are quite computationally intensive, the convolution whole process. So it was difficult to really realize them without a very fast computer with the GPU. So let's see, one of the advantages of this convolution neural network is, here you need not select the features. Feature extraction will be done automatically. The problem which was bothering us ever since this kind of learning system came into being was how to extract and how to select the feature. In convolution neural network, you need not bother about it, because the most important advantage of CNN, convolution neural network, is that the feature extraction will be done automatically. And at the same time, you can use it as a classifier. So it will do both feature extraction and classification. Only thing that you have to give is the labeled training pattern samples. So the training pattern samples in any case will have to be given. So as you can see that there may be images, there may be videos. Video means what? Series of fixed images, stationary images, say 30 frames per second in a video camera. So these 30 frames, each frame becomes one signal sample. Similarly, speech signal. If you suppose sample it at, the human speech signals, they are they go up to 300, from 300 hertz to 3300 hertz, almost 3.5 kilohertz. So in this whole spectrum, the male voices are rather on the lower side, female voices are a bit shrill, and they occupy the higher side of the spectrum. But then if you have to sample it, the sampling speed may be 10 kilohertz per second. So every sample value that becomes the input to your network if you want to to classify. So the basic structure I am just writing with a very simple model. Suppose you have to classify the set of the character patterns, say 3. So here some of the things are you have to do 3 different operations. One is the convolution operation. That's how the name is. And the number of such layers in the previous slide I had shown that there is only one hidden layer. Here the number of layers will be much, much more than one. At times it may be even in hundreds or thousands layers. So huge number of layers, and that makes this computationally a little bit expensive. But then the convolution neural networks are very good. You need not think about the feature extraction, and its classification rate also is very good. As you can see that using that red, rectangle, that part is the feature extraction unit, and the blue part, that is the second part, it is the classification unit. So in the feature extraction unit, what do? That the entire pattern, say 3, you make it in the form of a 32 by 32, simple pattern. If it is a colored image, then 32 by 32 into 3 RGB image. Now each of the pixels will have to be sent to the feature map. So what will happen from 32 by into 32? When you do the convolution, you will be getting 28 by 28. Why? Because the outer layers all will be removed, and it will be only 4, 2 from top, 2 from bottom, 2 from right, 2 from left. So ultimately, it will be reduced to 28 by 28. That is the convolution value. And then it is known as you have to do the subsampling on a 2 by 2 sample. In fact, as I was mentioning, that it would have been better if I could use the pen. So 2 by 2 subsampling, I have shown it in the next slide. And then again, you get say 14 by 14 features. Because from 28 by 28, if you take 2 by 2 and then make 1, that is for every 4 pixels, you make 1. So you will finally get 14 by 14. Similarly, again, you do the same operation of convolution. Convolution we are doing on 5 by 5 convolution. The original image was 32 by 32, and then you take a 5 by 5 kernel, you do the convolution. You know what is meant by convolution, multiplication and addition. So similarly, again after the S1 layer, you do the convolution, and then you get another feature map. Then you do again the subsampling. Similarly, in a series of such convolution, subsampling, etc., it goes on. Final class is a fully connected, like backpropagation, whatever I had shown earlier, you have got the outputs. So this is, basic structure with one, a gun type of thing which is there in the input. As you can see that you can convolve with the trainable filters. Again, the max pooling. This is that whatever I told earlier, it is known as that 2 by 2 subsampling. You take only the maximum value of the 2 by 2. This is known as max pooling. Now I have to go a little bit fast now. So a feed-forward neural network with a special structure, that is the automatic feature extraction. And what are the utilities of that? As you can see that in a classifier, whatever I had shown earlier, in a traditional neural network, all the input layers are connected with all the hidden layers. All the hidden layers are connected to all the output layers. So many ways in the multi-layered perceptron model with error backpropagation. But here, the basic structure is such that, as I said, only the feature map and then their convolution, then max pooling, convolution, max pooling. In between, there is one thing which is known as ReLU. The sigmoid function is a nonlinearity. Here also we use that kind of a nonlinearity here. So there are three important concepts in this convolution neural network. One is the local receptive fields. One is there are shared weights and biases. And the third one is activation and pooling. Activation means a nonlinear function. In every neuron, as I said, that you have got a nonlinear function like sigmoid function. Here also you have to use one such nonlinear function. And then pooling is known as max pooling. That is also a nonlinear function. A 2 by 2 matrix, they will be converted to the to a single number, which is the maximum. Let's now see, unlike in the previous case where every neuron was connected with every other neurons, here this is known as receptive fields or local receptive fields. In case of convolution neural network, all the nodes are not connected to all the nodes of the neural network. But then each node is connected to only few neighboring nodes of the previous layer. So this is very important. This is a traditional multi-layered perceptron. As you can see that this is what the new, the deep learning method, what it does. W1, W2, W3, these input layers are connected to only these values. So not that everything is connected to everything else. So in a particular layer, all the nodes have same sets of weights and biases. So all the nodes. So the biases and the same sets of nodes are there. Here it is, W1, W2, W3. And in the next three, there are W1 dash, W2 dash, W3 dash. So these are the differences. The correlation or the convolution, as you can see, 3 by 3. If you take, and here also 4, 0, 0, 0, 0, 0, 0, 0, minus 4. This is known as a convolution kernel. If you do the convolution operation, then you multiply 0 into 4 plus 0 into 0 plus 0 into 0 like that. Finally, you get minus 8. So now, instead of 1, which is the source pixel, that is the, the central pixel of the window, that will be replaced by minus 8. So that is the process of convolution. As you can see, as I said, that only this is localized. The neurons are only localized, and this is known as local receptive fields. So as you can see that these 4 are connected to this neuron. The next 4 are connected to this neuron. The next, this left, bottom 4 are connected to the left bottom here. And then this is connected to that neuron. So as you can see, that is very interesting. Not that every part of the image is connected to everything else. When I'm looking at the eyes of that cat, I need not look, or I do not have anything to do with the tail of the cat. That will be taken care by another set of neurons. Got the point? So a particular field, which is known as local receptive field, is connected only to a localized thing. So this is a major difference between the conventional neural networks and this convolution neural network. There are these 3 interesting things. Local receptive fields, everything need not be connected to every other neuron in the next layer. Feature map. Local receptive field is translated across the image to create the feature map. And then convolution, this process is the most important thing. And each neuron will have to be given the same set of weights and bias. So in any given layer, this is very important thing. And they are detecting, what are they doing? All these neurons, they are detecting, edges or blobs or something like this. Pooling, as I was mentioning, that this is the subsampling thing. So this is the nonlinear subsampling. because in the process of pulling, we are finding only the maximum value of 2 by 2 matrix. That's why it's known as max pulling. So here, to make it more simpler, we have shown simple kind of things like, say, a single depth slice. If we get like this, then what is the final output? 1156. Highest value is 6. So after max pull, this is a 2 by 2 filter, you get 6. So convolution, activation means that nonlinearity, that sigmoid function, as I said, and pulling. These are the three important things: convolution plus activation plus pulling. This makes a deep learning network. And then activation functions, as we said, that in the previous case we had taken in case of normal neural network, a sigmoid function. Here you can say ReLU, which is rectified linear unit. What is this rectified linear unit? This is nothing but a rectifier. You know, x and 0, whichever is, if x is greater than 0, then it should be x. If x is less than 0, it should be 0. Whichever is higher, it will be replaced by that. So this is maximum of 0 and x. So this is a rectified linear unit, which is, because in the previous slides you have seen that this activation function is very important in any neuron. A smooth approximation of this thing is log of 1 plus exponential x. This is known as soft plus. So log of 1 plus exponential x means what? See, suppose if x is very large, then what will be the value? Log of very large number will be that large number. If it is much more than 1, then it will be log of exponential of x, which is x. If suppose x is 0, then exponential of x is it will be log of 1, and then it will be 0. If it is x is minus infinity, if it goes to negative, then it will be log of how much? 1 over exponential infinity, that is log of, it will be 0. That is log of 1 is it will be almost 0. So it will be log 1 is 0. So anything which is negative should be 0. Anything which is positive will take the value of x. So this is a smooth approximation known as soft plus. And the third one is known as still more smoother approximation of rectified linear unit. That is the derivative of this. If you take the derivative of this, you get 1 over 1 plus e to the power minus 6. Again, that same kind of our sigmoid function. As you can see, that soft plus and this rectifier, these two are having this kind of activation function. So you can use soft plus, which is gradually changing. So activation and pulling together, because all the kernels you have to find out and then do the convolution, then you do the activation, that is using ReLU, and then you do the pulling. It's very simple. And that becomes, if the original input image is 128 by 128, next it will be 64 by 64, next 32 by 32, next 16 by 16. As you can see that every 2 by 2 becomes 1. So it is just getting half. And then finally, this whole thing will be in the form of a single row vector or column vector, and then you classify it using the final classification. So one of the things is, for example, the registration number of this car, vehicle recognition system. As you can see that, as we said, that when this convolution neural network you are designing it in many layers, not one, not two, in many layers. So in the first layer, you find the low-level features. Second layer, slightly mid-level features. Third layer, high level feature, that is, high frequency feature. So there is one, face recognition, face net is there, cow net is there. So they are useful for this kind of recognition. Now here, the images are such that this is, Sarah, this is the girl. So the images, as you can see, that initially the first set of, the layers, they are finding only the edges of the face. That is, edges means the eyebrows, the eyes, the hair, everything, the lips. So they will only be found, and then along with that, so they are distributed over the face. And as you can see that in the second layer, you can see that some of the things are very well understood. And in the third layer, you can see that how the entire face has been. So initially you find the high frequency, that is the edge detector, where the edges are only found, blobs are only found. Then in the middle layer, you do again mid frequency filtering, then the low frequency filtering finally. So you can see that how gradually you are extracting the features and you are taking the things. So in convolution neural network, in fact, I have been taking much more time. So in convolution neural network, the compute vectors for n-grams and groups. Now this is very important, that how the convolved features are getting, are getting port 3, etc. So main CNN idea for text is compute vectors for n-grams and group them afterwards. So this is a feature map, then max pool, and then you go on doing it. I will now, very quickly go to the next one, which is known as recurrent neural network. Now in recurrent neural network, even in convolution neural network, what was the problem? The problem was that if something is, coming as a linear sequence, then you are unable to solve that problem. Suppose in the case of natural language processing, a language means you have spoken something, then you speak another word, then you speak another word. Mathematically, this is known as the operation of concatenation. When one word is spoken after another word is spoken after another word. So at T1, suppose you have got some input H0. So this is known as a recurrent neural network. In recurrent neural network, each of these neurons, it has got one input, and then this is one hidden state and then output. So initially, suppose the hidden state at T is equal to 1 is H0. Now this hidden state is the main thing here, and then the hidden state, it gets propagated at T is equal to 2. Here there is a concept of time. In the previous cases, there was, in majority of the cases, there was no concept of time. But here you have got the concept of time. That means you are having in the time string of the events which are taking place, whether it is a video or it is a set of, string of values, or it is a string of words which makes a language. So in natural language processing, these recurrent neural networks, they become quite useful and quite widely used. So this is known as a vanilla RNN cell. And here the neurons, because as I said that every neuron, it must be having some kind of, the weighted sum, and then followed by the nonlinear function, ht minus 1 and ht. Here we have used the nonlinear function as tan hyperbolic function of w and then x1 ht minus 1. So at every level, as you can see here, that the vanilla function, that is the nonlinear function, it will be given by tan hyperbolic function. So tan hyperbolic is also like that, whatever is shown there, somewhat like, our sigmoid function, but then it is much more sharp. And that sharpness also has got its own importance. So RNN, suppose the food is extremely good. After I say everything, then only this is a sentiment classification, then only its final classification will be either my sentiment is good. If I write the food is extremely bad, then the final classification will be thumbs down, it is bad. So sentiment and classification, till the whole thing is talked about, you cannot come to a certain, any kind of, decision making. So in case of such, time series, whether it's, video or whatever it is, it's very difficult to finally come to the things. So RNN is quite widely used. And then finally you again in like, it is also part of our initial, whatever we have done, that is the deep learning method or convolution method. So sentiment classification. Finally, I will tell you about some of the very important, like what are the problems now? Suppose if somebody has given you this picture. In this picture, there is a dog which is hiding. This is possibly a place for taking our food. During our lunch break, you have all taken food in Kolaghat mess. And this is one of the places where the plates were kept in the Kolaghat mess, dining hall. And a dog was sitting. If you go now, you will find the dog. Just assume, since you are sitting at your home. So this is the very typical thing in any, in any Indian scenario. Now, what happens is you have to write a caption that what is this? So writing a caption is a very important thing. That means you have to see the whole thing, see the context, and then you have to find out that this is a dog is hiding below a dining table. Okay, so the whole thing will have to be written after the entire set of image is processed. So it's very interesting that how using RNN, that is recurrently you are doing. Recurrent, as the name suggests, it's a neural network which is being used recurrently. Suppose there is a very interesting problem of the video surveillance. You have got a camera, video camera, and you are taking the images of the output. And the camera is supposed to work 24/7, 365 days a year. In fact, currently the company in which I was working as a research head. Then the company was sold to another bigger company, and then the Indian one gentleman, he has come back to Calcutta, and then you will find that many of these on the streets there are some video cameras. These are all initially done by me. Now here, one of the interesting things, me means my group of people. Now, what is the problem? The problem here is very interesting. That is the environment I talked about. Suppose there is an output camera. Now that camera is continuously taking the photograph. Now it is daytime, it becomes noon, the sunrise, the sunshine will increase, and then gradually the sun will go to the western horizon and it will be sunset. And after that sunset, it will be all dark. But your camera should keep on working. So this is very interesting, that your video, one after another you are taking. Suppose you are doing the surveillance of the cars on the road, and there is no external light. So even if when there is no light, your camera, you cannot say that there is no light, so it will not work. It has to continue working. So this is again a very interesting problem where you need to have this kind of a deep learning where the video using this deep learning should be able to model the output environment continuously and then come to a conclusion that even at night it should be able to see that, okay, the car is coming. Although you can see that even in human case, you have just got into a cinema hall when the cinema or the theater has just started and it was all lighted outside. You have entered the cinema hall, suddenly it becomes all dark. What do you do? For a moment, you stand because you can't see anything. It's all dark. And then gradually you will find that human, the sensory organs, that means the optical part, it works in such a way that initially it does some kind of a, the Gaussian, that is the low pass filtering, and then we can find out the high pass filtering. It's known as kind of a log filtering. And then gradually our eyes, it becomes sort of with the environment that it is absolutely dark, it gets adjusted. And we find out that, okay, this was my seat. And you can go to your seat. After some time, you'll find that it has got adjusted. So it is very important that adjustability is important out here. There are lots of very interesting problems, which are, as I was mentioning, that, for example, the cricket test match is going on in England, and then they have given big hoarding of in a certain place of Dunhill cigarette or Rothman cigarette. Okay, and you are all sitting in Lords of England cricket ground, and what you want is the camera should continuously take that image, this video, but then instead of the advertisement for Dunhill cigarette, it should give the advertisement of Bodoline here, which is an Indian product. Bodo Calendula. How do you do it? That means you have to classify, you have to interpret that, okay, where these advertisement is kept. You have to interpret what is written there. You have to very accurately identify them. And then replace that part by your own advertisement. Because I am an Indian viewer, I am seeing the same match from India, from my house. Okay, I want that, okay, some Indian advertisements are there. So Indian companies may like. So if you are sitting at England, you are seeing the same match, but with the British advertising. And I'm seeing the same match with something else, with the Indian advertising. So far as the business policies are concerned, they are becoming very, very important. So there are plenty, and I have not touched upon the healthcare, which is so dear to my heart. But then time is not there, and there's plethora of applications in medical science and technology, mainly in the area of one-dimensional and medical image processing, pathological image processing, radiological image processing, telepathy pathology, and everywhere at the end of the day, you need artificial intelligence and neural network, sort of the deep learning. So with these few words, I conclude here. If anybody has got any question, you can ask me. I will be really very glad to answer you. Because all on a sudden, I thought that, like this kind of a nonlinearity, I will have this kind of a nonlinearity. I'll stop here. Or a threshold kind of nonlinearity, I'll stop here. Thank you. Yeah, any question?
If anybody have any question, please, you can mute yourself, turn on yourself, and you can ask the question.
Yeah, I cannot hear. Can you be a bit loud?
Sir, there is one. Sir, there is one question in the chat box. Sir, can you hear me? Sir, I'm audible? Hello?
Hirok sir, you're audible.
I'm asking that if there is any question.
Sir, yes, sir. Sir, there is one question in the chat box. Is it possible to convert waves data like EEG into binary form?
And which one?
Is it possible to convert waves data from EEG into binary form?
Weight vector.
Wave data. EEG wave बोलो ना, EEG wave.
Oh, EEG. Yes. EEG, yeah. I mean, all kinds of such one-dimensional signals. What you can do is because in any case, such signals will have to be digitized, and then after digitization, you get it in binary format only. And then you have to do the processing. So a lot can be done from EEG. One of the things which is being currently tried in many places, that is your mental condition, your sentiment, your anger, your current psychological state of mind from EEG signal, whether we can identify them or not. So this is an important problem. Other than just finding out several diseases arising out of for example, the convulsion is a very important area, and there are so many diseases arising out of convulsion, and each one of them, there are you will be surprised that there are more than almost 70 to 80 different types of diseases which are sort of epilepsy. Usually we people, we know that, okay, this is epilepsy. But even epilepsy can be classified into so many different groups. So similarly, when we say that, okay, your learning system will be able to classify in two classes, for example, normal, abnormal. That is not the thing. Amongst the abnormality, whether it is from ECG or from EEG, there are so many types of abnormalities. So interestingly, it's not a two-class classifier everywhere, but you have to think about, multi-class classifier. If it is abnormal, for example, an ECG signal, then the abnormality, it may be due to the rhythm of your heart signal is not there. Since there is no rhythm, these kind of diseases are known as arrhythmia. A means no, rhythm means rhythmia. So arrhythmia is a very important disease. So arrhythmatic tachycardia, bradycardia, there may be several diseases. So interestingly, now if you make a network, if you train a network so that it can be able to classify a pattern not only in normal and abnormal, but in multiple number of classes, then that will be the most important contribution. Lots of things can be done. Today, machine intelligence is being used in almost so many areas. Initial days we are using it in only standard image processing, simple, pattern recognition, simple speech processing. Now it is being used everywhere, sentiment analysis in healthcare. It is being used in a very large way in business, because the business understanding process, they are very important. The businessmen, how they will be taking the decision regarding their, capital accumulation, profit and loss, everywhere. To understand they are using the. So initially I thought that I will give you a lot of examples, but then maybe sometime later on. Yeah. I cannot hear. Can you? Can you slightly be louder? I can't hear. Any question? Hirok,
Yes, sir.
any other question?
Sir, I have not seen in any other question in the chat box.
Okay, so if anybody has got any other question, you can send it to the coordinators, Professor Hirok Maiti, and then I will be answering them.
Hello, sir.
Yeah.
Hello, sir.
Yes.
My name is Vasudev Haldar. So I have a question, sir.
Yes.
Actually, I am working on heart disease, heart disease. So, sir, I have used basically ECG signal, and I have used rough set technique.
Okay.
And multiple number of disease will be classified using rough set. Okay, sir. So question is, sir, without if I use neural network or CNN, then it will be better or not?
Yes. In fact, I mean, just like the neural network, it has been fuzzified. We call it as fuzzy neural network. Similarly, it can be a rough neural network.
So actually, I have used a rough set technique, basically rough set.
Right. So rough sets are very interesting kind of procedures.
Okay.
So you can surely use it here. In fact, I was planning to now take one student who will be using such kinds of methodologies like say rough sets, soft sets, and then implement them in our the deep learning paradigm.
Okay, sir, if I use multiple type disease, like actually I have used basically 4 type of disease, heart disease, inferior, interior, anterior lateral, inferior lateral, right, sir? This type for 5 type of disease using rough set. So if I actually I want to my work basically convert to neural network or CNN. So if I want to change my work rough set to this, if any problem?
No, there will be no problem. It is good, brother, because in rough set also, your basic approach somewhat like fuzzy, but more, in my opinion, much better than that.
Okay.
Because the sets as you are defining there are more logical.
Okay.
Since you are having, 3 different regions. One is certainty that this belongs to this class. Another part is it definitely does not belong to this class. And in between is a rough region where you say that I am not too sure. So the whole idea is a rough region will have to be reduced, and how to do it.
Yeah.
All the problems are essentially rough or fuzzy in nature. The real life problems.
Yes.
Some cases you can surely say that, okay, this is a bradycardia.
Yes.
Some cases you can say that surely it is normal, no problem.
Yes.
But in between them, that rough zone, which needs to be slightly reduced in a sense, and that classification accuracy can surely be enhanced by using such kinds of networks. Yeah.
Okay.
Neural networks. So that is interesting. Yes.
Okay. Thank you, sir.
Very good. Yeah. Yes. So any other question? Any question that comes to your mind?
Sir, several participants have shown about their interesting session. That this is a very interesting session.
Sir, louder.
Yes, sir. In chat box, several students
If you can speak a little bit like Vasudev, I could hear everything. A little bit louder if you can speak.
Several participants have appreciated your session. Already they have mentioned in the chat box.
Okay.
Any other question, please?
Okay. Otherwise, later on also somebody, if you have got some questions, you can ask later on also.
Yes,
Okay. So all the best to all of you. And I wish this FDP a grand success.
Thank you, sir. Sir, we are very much fortunate enough to get you as a resource person in this program. On behalf of organizing committee, I am extremely thankful to you, sir. I hope all the participants will benefited from your excellent presentation. And not only that, I think the basic concept about the difference between artificial intelligence, machine learning and deep learning is clear to them. And I hope your simple way of representation is always encouraged and motivate to us in real time. It will be very much helpful to work in future. Thank you, sir, for spending your valuable time with us. Thank you very much, sir.
Okay. Thank you very much. And all the best to you.
Thank you so much, sir. It was really very informative session, and I really appreciate that. And I really got lots of information about the ML. And I want to thank you so much, sir. God bless you.
Thank you. Thank you very much. Thank you very much. Yeah. Okay. Wish you very best, all of you.
Thank you so much, sir.
Thank you, sir.
Thank you. Thank you. Okay, then I am leaving now.
Yes,
All the best.
Okay, sir. Yes, sir. Thank you, sir.
One announcement for the participants. Today we have seen some of the participants have joined with unknown user. They have not written their name, so their attendance may not be counted. And some of you have written only the code number. Also, it's not possible to trace out names, so it is not possible for them also. So for tomorrow's session, link will be sent today at night, and tomorrow we will start again at 9:30. So we will join at 9:15, just 15 minutes before of this program. So thank you.
Excuse me, sir.
Yes.
Sir, I am having a problem that yesterday I told the team that I already messaged to a team that I am logged in with the Atal, that is the another email ID forum.shy@utu.ac.in, and right now I am logged in with the another email ID. Is it okay, sir?
No, email is not problem. Your name is showing Forum Ajay Shah. Is it okay?
Yes, okay, that's fine.
Basically, we will take this name only. Okay.
Okay, fine, sir. Thank you so much, sir.
Sir, I have also a query. I have also been speaking. So my name is giving.
Yes, I understand. It is Dinesh.
Yeah,
okay.
yeah. So
actually, if it starts, I have seen the chat box your name, Dinesh. I can remember it. Okay, no problem.
Okay. Thanks a lot.
Okay, thank you.
Deepak.
Yes.
Hello.
Hello.
Actually, chat box is disabled. Why the chat box is disabled?
No, maybe this is chat box is
no. I think you are using mobile phone.
Sir,
no,
sir, it may be if you use the desktop version, sir, it may be due to the browser. Maybe because it will be better if you use the Google Chrome. Maybe.
Oh no, I have only used Google Chrome, but while I open the chat box, it is seen that this is being disabled by the why that is happening?
All of us using the Google Chrome, maybe the Google Chrome is not updated or something else. The same set we are also using, and we are able to get the chat box.
So might be
most of the participants are writing box.
Oh, this is from the mobile phone. Excellent first day. Okay.
Hello.
For me also the same problem, sir. Chat box.
This is excellent first day. Initial glitches were there, but overall it is very good coverage for the first day. Hope the remaining 4 days will also be equally eventful. Okay, thank you.
Thank you,
Thank you,
sir.
sir.
Thank you, sir. Thank you.
Sir, we have just asked for the information whether our name is visible for the sake of attendance, but we have not received any information from your side, sir.
Yes, yes. Your name is, I mean,
Yeah,
visible.
Young Nirmala, sir. Yes, sir.
Yes, yes. It is
Okay,
visible.
thank you, sir. Okay.
Hello, sir. Hello.
Yes, yes, yes.
Hello, sir. I am Orindam Giri. Whether my name is visible to you?
Yes, yes. You are visible. Your name is visible.
Okay. But when I am going to the chat box, it is saying that you are no longer a participant. Sir.
There may be.
In the chat box, your name is also visible and
Okay.
and this time also your name actually showing Orindam Giri.
Okay.
I mean,
Okay. No problem. Okay. Thank you.
Sir, we'll be able to get the content of the presentations, what we have listened for the past speeches.
Yes.
We'll try to
We will share.
share that. We'll share the video link, of course.
Okay, sir. Thank you, sir.
Good afternoon, sir. This is Ravichandra Alati.
Good afternoon.
Sir, in my chat box also it is disabled, not able to.
Sir, this is a common problem. Maybe from the browser or from your mobile phone.
Actually, sir, we are given the same setting to all the participants, and still some of the participants are getting that, and we think that is a local issue. Please, you try to update the browser. If it is Google Chrome, I think that will be more accurate. If it is Google Chrome and you are still not getting the chat box enabled, please try to update it.
Actually, I installed the app, sir. Microsoft Teams app only I am using.
Sir, good evening.
Sir, good evening, sir.
Actually, in some handset, that problem is coming. Okay, so it is preferable. Please use laptop and use Chrome browser for better experience.
Sir, good evening, sir.
Oh, yes.
Sir, in mobile device only just can able to communicate, sir, in the chat box, not the participant.
Yes. I'm basically some of the mobile handsets are giving
Some
that
mobile
problem.
it is done.
Please check it, sir.
So basically, from our end, we cannot do that. So maybe you need to update the OS or something like that. So basically, otherwise, so it is
No,
preferable.
most of the attendees are using mobile devices.
No, you see, some of the participant is also using the mobile devices and their chat box is enabled. That in the chat.
I enable only for guest. I observed only for guest people.
No.
Participants not allowed.
No.
Oh, yeah. With chat.
Sure.
We have given same link to all the participants. Same link.
Yeah. Same problem. We have
Same permission and some only few of you actually facing that. And for that, we can ensure that there is no, restriction from the administration or our side. That may be some local issue in the local device. For that, that is not supporting this chat box or all.
Sir, I have one doubt regarding
meeting.
this.
You have to give some permission, it seems.
No, same permission we are giving to all.
Okay.
We are not restricting to anybody for chatting or something else.
Okay, sir. Thank you, sir.
Sir, my name Alati Ravichandra. Now I am using this Microsoft Teams, my institution organization mail ID only. Is there any problem to?
No problem.
Yeah, okay. Is there attendance problem? No issue, no, sir.
No issue.
Okay, thanks.
Okay, thank you. If there is no question, may we leave now?
স্যার এখন জয়েন করা সম্ভব? আচ্ছা আচ্ছা আচ্ছা, পাঁচটা 15, আচ্ছা ঠিক আছে। একদম শেষ করতে স্পিকার কালকে 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 না দেওসিস মানে কবে আছে? লিংক দিয়েছে 8 তারিখে আছে। লিংক দিয়েছে আইডিয়া দিয়ে দিন এখন বুঝেছি আর কমেন্ট বুঝতে হ্যাঁ স্যার বারো বলছে আপনি লিখছেন ক্যাট করছেন। আচ্ছা না না স্যার বলছেন জমা করতে এটা রেকর্ডিংটা বন্ধ, রেকর্ডিং বন্ধ। এটা কালকে লিখে রাখতে হবে তো